Hi students, welcome to physics class. Today we are going to discuss some important concept. Now question. Define angular velocity. Define angular velocity. Give its units. Give its units and dimensions. Dimensions and prove V is equal R cross omega. Now see answer. Take a circle. Here this is radius r in anti-clockwise direction. Angular velocity is there. Now the tangent is velocity vector. Now the angle between them is 90. Here also the angle between them is 90. Now take here, this is angle theta. Consider this is a point O. This is point A. This is point B. This is R. Now see velocity gives translatory motion. Velocity gives translatory motion of a body and angular velocity gives turning or rotational motion. Rotational motion of a body. Now let a rigid body rotating about rotating about y-axis. With a constant angular velocity, with a constant angular velocity omega. Now consider a point B on the body which is at a distance r, small r, from origin. Since velocity is perpendicular to since velocity is perpendicular to velocity is perpendicular to both omega and OB. Now method 1. Method 1. Take a circular motion. It is angular frequency omega. This is O A B. This is angle theta. This is R. This is velocity V, tangent. Now angle is 90. Here also angle is 90. From triangle ABO sin theta is equal to opposite side by hypotenuse. Consider it is R. So sin theta is equal to what is opposite side for this angle? OB. What is hypotenuse? AB. That is OB OB by small r. Therefore, OB is equal to r sin theta. Consider equation number 1. Therefore, velocity is equal to angular velocity is equal to perpendicular distance into angular velocity. Therefore, velocity is equal to perpendicular distance is O B into omega. Consider equation number 2. Now but OB is equal to r sin theta. Consider equation number 1. In 2, V is equal to r sin theta into omega. Equation number 3. Therefore, V is equal to r cross omega in the form of vector notation. Equation number 4. If case. If theta is equal to 0 degrees, then velocity V is equal to r omega r sine 0 degrees. Therefore, V is equal to omega into r into 0. Since sine 0 is equal to 0. Therefore, V is equal to 0. That means velocity is minimum. Next case, if theta is equal to 90 degrees, therefore V is equal to omega r sine 90 degrees. Therefore, V is equal to omega r into 1. Since sine 90 degrees is equal to 1, V is equal to omega r, that is maximum. Now, if theta is equal to 180 degrees, then V is equal to r omega r sine of 180 degrees. V is equal to omega r into 0. Since sine 180 degrees is equal to 0, V is equal to omega r is nothing but 0. That means minimum. Now, method 2. Take x-axis and y-axis. Here it is angular omega in this direction. Take a velocity vector, makes an angle theta with x-axis. Obviously, the point is, consider B. The point is O. Now, both are vertically opposite angles. Now I draw a perpendicular here. The point is A. Here the angle is 90 degrees. Consider it is R. This is x-axis. This is y-axis. From triangle O, A, B, sin theta is equal opposite side by hypotenuse. Therefore, sin theta is equal, what is opposite for this one? OA. Where is hypotenuse? OB. That is equal OA. What is OB? R. OA is equal R into sin theta. Consider equation number 1. But velocity is equal to perpendicular distance into angular velocity. Therefore, velocity v is equal to what is perpendicular distance? OA. What is angular velocity? Omega. Consider equation number 2. Now 1 into. Now equation 1 in 2. Therefore, velocity v is equal to OA. What is OA? Is R sin theta into omega. Consider equation number 3. Therefore, V vector is equal to R vector cross omega vector. Equation number 4. Now, units. Omega is equal to V by R. That is equal to meter per second into 1 by meter. That is equal to radian per second. Therefore, omega is equal to what is the unit? Radian second to the power of -1. Now, dimension formula. What is the dimension formula? T to the power of -1 or m0 L0 T to the power of -1. This is about relation between angular velocity and velocity. Now, question. Express angular velocity in terms of the rectangular components rectangular components linear velocity and position vector. This is the question. Once again I am repeating. Express angular velocity in terms of the rectangular components of linear velocity and position vector. Now solution. Take position vector r is equal to xi plus yj plus zk. Now velocity v is equal to vxi plus vyj plus vzk. But angular velocity and velocity and radius are perpendicular to each other. Perpendicular to each other. Therefore, V vector is equal to R vector cross omega vector. I, J, K. Take X, Y, Z, Vx, Vy, Vz. Now take x-axis, along x-axis unit vector I, along y-axis unit vector j, along z-axis unit vector k. Now consider here y, z, vy, vz. Here z, x, vz, vx. on k vector x, y, vx, vy. This is origin O. Therefore, that is equal I into omega is equal to I into y, v, z minus z into vy plus j into z v x minus x into vz plus k into x into vy minus y into vx. Consider equation number 1. But omega is equal to omega xi plus omega yi yj plus omega zk. Equation number 2. From 1 and 2, omega x is equal to y vz minus z vy, omega y is equal to z vx minus x vz, omega z is equal to x vy minus y into vx. Consider equation number 4. My dear students, we have to solve the numericals on the basis of velocity, angular velocity and position vector. I hope you understood this video. Thank you very much for watching this video.